Good morning, everybody. Welcome and good day. We're going to go ahead and get started. Thank you for joining us to kick off the year. We have an exciting strategic discussion planned for you on industry verticals and how they're implementing and leveraging big data. My name is Joanne Martin, and I have the distinct pleasure of being the VP of Marketing at Impetus Technology, and am your host for today's session. I'm very excited to be able to introduce to you the thought leader for today's session, Anand Venugopal, Director of Business Development for Big Data Services here at Impetus. Anand, or AV as we refer to him, has been a leader in building the Big Data Analytics Consulting Services practice at Impetus Technologies over the last 3 years. Prior to joining Impetus, AV had a distinguished 17-year career in telecom, interactive entertainment, and high tech. During our session, AV will share with you some key learnings and perspectives from proven experience in the big data space. So without taking any more time, let me turn this over to AV.
Thank you, Joanne. I hope the audio is all set up now. Apologies for those minor glitches there that you might have heard, folks. Greetings to all our live attendees. Good morning, good evening, and welcome to this webinar, whether you are a live attendee or listening to this as a recording. So it's a privilege to be here speaking to you all today to share our experiences and learnings from being a big data analytics consulting and services company that is exposed to multiple industry verticals. And over the last 4 years, we've had the privilege of working with pretty large enterprises, helping them through their technology strategy on big data and the implementation phase. And those are the learnings that we are attempting to bring to you today. I've had, in my role, the privilege of actually being right there on the field in a consultative role, partially in front of our customers, and I'm excited to share our thoughts today. So getting into what we're going to talk about, first of all, we're going to get on the same page in terms of the definition. We'll have a much, awaited or a topic that has a lot of interest in terms of value. And then we'll look at the core subject area, which is the use cases and vertical patterns, and then a discussion on how to. So on the definition, I think the industry by now has pretty much come onto the same page in terms of a simple but effective definition. When your traditional information systems cannot store, process, or analyze your data, and because of its volume, variety, or velocity, in a cost-effective and timely manner, that's when you have a big data situation. And that has been fairly consistent. It's not just a cliche that we're choosing to repeat here. In our experience, our customers have come in with a variety of situations, starting with basic scenarios like, hey, I need my reports and my information way earlier, not in as many hours or days it takes. A lot of customers are trying to move as close to real-time information as possible, and of course the sheer volume and processing advantages of big data. So moving forward to the fourth V, as it is known today, the value of big data, how is it monetized? So there are two angles here. One is cost, and the other is upside or top line, and we'll look at both of them as we go. So here's a piece of information that we gathered recently and validated by our own experience as well. Capex savings of literally, 95+%. And where that comes from is $20,000 to $180,000 per terabyte for traditional DWBI versus a Hadoop-based strategy for the same thing. And on a Hadoop-based strategy, it is $800 per terabyte, including 24/7 support. And from the second year onwards, it's just $550 per terabyte. So clearly an immense cost savings, and we're not saying this is a complete replacement strategy, but there are certain tasks that can be offloaded to a Hadoop and big data infrastructure from your traditional high-cost relational database infrastructure. So that was the cost and Capex angle. Looking at the top side, the top line, or new value generation. In this chart, you see on the y-axis you have quality of management decisions. Eventually, every executive decision is what makes or breaks value for the company. And the more accurate, the more relevant, the more quick executives are able to make those decisions, value is immediately added or lost. So at the bottom you have intuition, which is the highest paid person's opinion pretty much. A lot of us probably go through that in daily lives where someone says, well, we've done this way and we've done this for so many years and this is how it works and this is how we're going to go. Well, okay. The next level of maturity is the current generation of data analytics and BI as we know it, where the analytics is largely based on samples of data as opposed to the complete data set. And it only covers as much data as you have in your company or in your department. Now, there is a huge nonlinear swing upwards, and this chart by no means conveys real scale, or it's not really scaled to the dimensions. We think there's a very big nonlinear leap into the value generated by using big data, and where that comes from is by using, first of all, on the same dimension of data that you have, the complete data set as opposed to samples, and adding more vertical silos of information related to a particular subject. So the more and more related information you bring in, whether it is data from your other silos, other departments in the same enterprise, or third-party information, third-party data sources, including social media feeds, you're now able to make much more accurate, timely, relevant decisions. Just imagine things like, for example, a retailer saying, well, if I could can I stay with the same sales volume with maybe a 2% increase in price of a particular commodity or a product? That would immediately impact profits if he only knew and predict accurately if that move would not compromise sales volume. So just a simple example there. Moving forward, we'll see more and more examples. So before we go to enterprise context, I just want to touch upon an example that we all witnessed and we all saw and probably read about by now. The Obama campaign was hugely empowered in their win by big data analytics. They hired a retail analytics guru, and they had a 5 times bigger analytics team. And the key points that we want to convey here are on this slide. The first 18 months, they spent their time, first of all, aggregating all the data silos. They found they had relevant data across campaigns, across pollsters, across volunteers, across geographies. So the first thing they did in the Chicago headquarters was consolidated everything. They chose to model everything, like everything, right? Funding sources, what appeals generate, success, who are the swing voters, who are the crowd pullers, and just a couple of interesting examples there. George Clooney was found to be a great crowd puller in the demographic segment of 40 to 49-year-old females who tend to contribute a lot, and that actually pulled in a lot of money. Similarly, they had another star on the East Coast. And on the final weeks after the 3 debates, they ran 66,000 times simulations every night, and the results of those were used to allocate resources and focus on the swing states and which swing states to invest in. So in a closely tied election that was supposed to be closely tied, Obama ended up swinging 8 out of 8 swing states. And the example here for enterprises is both in revenue generation, right, which is for creating of funds, revenue generation, and deployment of funds on the cost side, optimization of that. Both were demonstrated in this example. So moving forward to now the core of our presentation, the analysis of big data use cases we're going to do in 3 dimensions. We're going to look at a few industry verticals. We're going to talk about, first we're going to talk about use case patterns, what they are, and then kind of matching to the value drivers of economic value. So on this graphic, of course, it's just a further illustration. On the left, the top left, you have various verticals, illustration of use case patterns and horizontal areas. So what are use case patterns? When we look at our big data analytics use cases that we've implemented and that we've been involved in across verticals, we see characteristics which make up common patterns. So the type of data analyzed in terms of the 3 V's, what is the volume, velocity, variety of the data. That attribute plus the nature of analysis or processing and information presentation, and consequently the technology stack. So these are the characteristics that make up a use case pattern, and the 3 use case patterns that we're talking about are batch analytics, multi-source batch analytics. 2 is real-time or near real-time event processing, and 3 is natural language processing. By all means, there would probably be more patterns that you can come up with, but just we're starting with these 3.
So great. AV, before we jump into having you discuss these use cases more, let's see what our audience says. So everybody, you're going to see on your screen a quick poll. It's only going to be open for 30 seconds. We're excited to get everybody's feedback. And we just want to know, what are you guys seeing more of? The batch mode, real-time, social media or natural language, or others? As you guys are answering this poll again real quickly, we're going to take a moment to ask AV some of the questions that come in. So AV, somebody wants to know, do you know which big data platform and solutions the campaign used?
Yes, we actually don't know the precise details, but it's likely to be something of the nature of what Hadoop offers. And I'm actually looking forward to go to the IE event on January 30th and 31st in Las Vegas, where the CAO of the Obama campaign is actually going to be making a presentation. So we're going to be there. We have our own panel event there, and I'm looking forward to that. Excellent,
excellent. I'm looking forward to that too. As it relates to use cases, what do you see in 2013 as where do you think people are going to be spending more of their time in discovery?
I think the mainstream of multi-source batch analytics that includes both structured and unstructured sources is going to definitely continue. There is an increasing trend that we are seeing for customers wanting to move from more batch towards more real-time data. And on the reporting and querying side as well, there are technologies now that enable you to do as close to real-time as possible with the launch of things like Impala and Apache Drill. I'm just going to get into that on the next slide.
Great, great. Well, before we jump in and let you go to the next slide, just a quick update for our audience. It seems that quite a few of you are seeing both batch mode and real-time, and let's see how that grows as AV continues his sharing.
Great. So I'm going to quickly run through these patterns and just the basic architecture template of these patterns, the first one being batch mode multi-source data analytics. So you see on the picture both unstructured and structured data sources coming in and into a middle block, which we're calling ETL or ELT, landing into a big data store, and the data being processed by analytics applications. We say ETL or ELT because in a technology like Hadoop, you could land the data and use MapReduce jobs to do the transformation on the cluster itself. Some of the bullets you're seeing there are just sample technologies or products. By no means are these intended to be a complete exhaustive list. Flume and Scribe are for the unstructured data piece. The Scoop and HeHo are typically structured data connectors to Hadoop. There's a plenty of custom connectors that we have seen from various vendors. And the data store, of course, is going to be Hadoop or Hadoop-like file system. There are a bunch of new SQL databases, clustered SQL, clustered relational databases. There's a vendor called Hadapt. There's, of course, the numerous NTP databases, including EMC Greenplum, Vertica, Aster, Oracle, Big Data Appliance, etc. On the last bullet is the Hive, Pig, MapReduce, Impala, Apache Drill. Those are all the technologies that enable us to query the data and convert them into the visualization layer. So moving on, we saw a 30% number, actually a little higher than the batch on real time from the survey that we just did just now. On the real time, focusing on the diagram below, the pattern is there's a stream of real-time events, whether it's transactions, whether it's sensor outputs, whether it's factory machines generating data, any of that kind of input leading into an event processing engine, something that's being able to take the real-time data feed, apply real-time business rules right there on the stream, produce alerts or control signals backwards, and eventually the stream of data settles in similar to any batch mode data and settles into the big data store where it can be a candidate for long-term analysis like analyzing patterns and the intelligence in that data. And the technology stack we use many times is Storm and Esper for the real-time event processing. There's a vendor called Edge Streaming. There are other commercial vendors in the second bullet, Streambase, Stream Insight, and IBM Streams, of course, which was created in response to the 9/11 disaster. And there are connectors like Kafka and other messaging technologies that are important here for the real-time data as a conduit for the real-time data. And the data store, in this case, would be something that could handle fast data ingest. And NoSQL databases play that role very well. And the extreme version of that would be, of course, in-memory technologies similar to SAP HANA. So that's the real-time pattern. And the next pattern we'd like to cover is, of course, the social media natural language processing. And this pattern we, again, see very often to cover and analyze all the natural language artifacts that enterprises have access to. And in our experience, we have seen people analyzing emails, people analyzing the notes field in a CRM database, which was never, ever visible to any BI tool. We've seen call center transcripts being analyzed, regular documents. All of these artifacts that now are being used to get much better, richer insights into all areas of enterprise operations. So the toolkit here is Natural Language Toolkit, NLTK. We have a text capability in R. We have used Apache Mahout for machine learning algorithms, and Lucene and Solar, of course. And UIMA is an example of an Apache tool for entity extraction. And there's an ever-emerging set of commercial products which are also very high quality, many of them, and we end up doing POCs to compare many of these in customer contexts. So those are the three patterns that we've observed. And coming back to the context of this whole presentation, we saw the three use case patterns, and we'll recognize and identify which pattern we see in which use case. Now moving on to the next dimension of value and where value is driven from. If you get to, without focusing on all the details in this slide, just the three columns, revenue, cost, and risk. Pretty much those are your economic value drivers, right? If you include profitability in the first column. So any use case such as pricing discounts, channel effectiveness, new product development, clearly advertising is a huge one, and upsell, cross-sell, recommendation engine, market basket analysis, all of those belong in the revenue and profitability area. There's a ton of, and at a low-hanging fruit, I would say, is the cost reduction use cases, and of course optimization. And we'll see examples of each of these in the coming slides. And of course, there are situations. I was talking to a person in a major credit card slash banking company. He said, on the risk front, upsell, cross-sell can probably take our profits up by 10, 15, 20%. But the risk side of the equation can wipe out our profits up to 100%. So clearly there is a huge focus in the financial institutions and other verticals on the risk side as well, and we see big data analytics use cases on all of these dimensions. So we'll see examples of them in the coming slides.
Great. Let's take a quick moment again and just do a quick audience poll. Where do you guys see the most value, and where do you see energies being spent? More on the revenue projects, those that generate revenue, those that are helping cut costs, those that are helping with risk mitigation. Real quickly before we share these results, I do want to let everybody know again, please bring your questions to the table earlier so we make sure we have time to get to them at the end. So I appreciate that. I'm going to have AV keep going now, and we'll share those results shortly.
Great. So we're covering the third dimension of this now, getting into the use cases for independent verticals. Starting with telecom, I come from about 13 to 14 years in the telecom space, and kind of just you chose to start with that because it tends to be my favorite. So large telecom networks, cable networks, have huge capital expense, and network optimization that might result even in small percentage point changes in improvement of utilization of the network create millions of dollars of savings, tens or even sometimes hundreds across large networks. So the first use case, and let me kind of introduce you to the pattern of these tables that you're going to be seeing in the next few slides. First column is the functional area, just like you see, it's kind of obvious. The use case pattern that we talked about earlier in the middle column, and the actual use case description very briefly on the third column. So on the first use case, correlating various device logs from the edge of the network, including customer premise equipment, the core of the network, assimilating all of that together to see if there are lower cost pathways, both in terms of the actual circuits and in terms of time utilization of the bandwidth, to reduce the cost of the network while keeping the SLA constant. So that was the object of one particular use case we were involved in. DPI of mobile apps data was a deep packet inspection. As you might know, telecom networks are sort of, unfortunately, just dumb pipes. When you and I are accessing our mobile applications and all accessing some internet property, and the network operators are very keen on understanding that traffic flow, which applications drive or consume how much data, and on the consumer side, which consumers are hogging the bandwidth so that they can take actions on either approaching revenue share agreements on the application side or do throttle so that they can balance out the network utilization across their consumer base. Again, this is a large data analytics use case involving batch processing. So quickly moving on to the next one, media and entertainment, where the value driver is increasing revenue or adding new product lines that might make new revenues or new market segments. So if you observe the triple play offerings from an AT&T or a Comcast or a Cox as examples, or Verizon, for example, these companies or these kind of networks have access to your and my internet usage, TV viewing, what advertisements we saw, when did we stop seeing it, when did we switch off the box, the mobile applications that we access from our iPhone, what did we do on our iPad, who did we call on our phones, and even what social media properties we're visiting, and of course their own customer service records. Now imagine that variety of data and consolidating that to get a single view of the customer. This case was all about, hey, when does the customer stop viewing this content on the TV and go and start seeing the same content on the iPad? Why does he do that? We lose revenue. We want to keep him on the television. Those kind of behavior patterns of users were being analyzed to create new products. So that was an interesting use case. The second one in this slide is one of our very own largest customers. They have access to DNS data, mobile transactions data, geolocation, number portability information, and they're quickly realizing that these data assets can be actually leveraged to convert them from a telecom network organization into an information service, and we are actively assisting them in the process using technologies like Hadoop and Cassandra and many others, actually. So ensuring we keep on time and keep moving along, financial services is a very attractive segment for all of us. Let me introduce you to a couple of use cases that we have taken into production with a very large customer of ours. Fraud accuracy, reducing false positives on fraud detection algorithms based on customers' individual transaction history. So what this is talking about is high-value, high-net-worth individuals making transactions that look weird, that look unusual, and the regular algorithms end up blocking them, thereby blocking a significant chunk of revenue, which was good revenue, which was good transactions. And individual transaction history was then analyzed to add further nuances and intelligence on those algorithms to let these good transactions pass, and net-net it created a significant surge in revenue for just that particular use case, and I'll share some of the numbers towards the end of the presentation. The other use case we did in a financial context was, of course, kind of a more of a retail use case there. It was batch analytics around merchant offers. So merchant offers to the right customers by putting a predictive score on a 0 to 1 scale of which customers might like which offers. You might be a 0.6 and the other guy might be a 0.8, and optimizing marketing spend on the promotions, and for the consumers it just led to much better, more targeted custom offers based on their own spending patterns. So those were a couple of use cases that we saw, and moving on to further use cases on the financial side. On the risk side, we have seen multiple organizations that deal with risk and risk assessment and credit, evaluating credit worthiness and optimizing their algorithms using new data sets that they've never seen before, which include insights into lifestyle of consumers, which typically was not utilized. They're now experimenting with that to get much sharper, more accurate risk analysis of credit worthiness. On the insurance side, we've seen interesting use cases of unstructured data and consumer social media inputs being evaluated by the auto insurance vendor or company to evaluate the quality and cost effectiveness of auto repair vendors so that they can direct their insurance paid repairs to the better vendors than the others. So that was financial. Now, we were surprised by one trend we saw in 2012, and we didn't do anything to cause this other than just marketing, but customers started coming to us from the manufacturing side. They heard of big data. They clearly looked back into their own factories and their own environments, and they said, gee, we have big data. And a couple of these examples are product engineering and process analytics being used in manufacturing contexts. So finding new patterns from product testing and increasing the quality or the yield rate of networking equipment that's being produced in factories in Asia, getting those data feeds from those factories every night or even hourly, analyzing that, see root cause analysis, prediction of faults, and thereby impacting inventory as well, and good quality inventory output. And the second case here is a case where factory machines, this is a software product vendor for the high-tech manufacturing industry, where 2 to 3 terabytes of data are being spit out by the machines on the factory floor, and there's both real-time analytics for statistical process control, for closed-loop feedback within 1 or 2 seconds, and we also needed to put together a batch infrastructure for long-term pattern detection and analysis. So moving forward on the manufacturing side, we have to alert customers for proactive quality engineering and recommendations. We feel that we've seen, in fact, upsell or cross-sell and new offerings possibilities for vendors like a Cisco or a Juniper or other networking vendors, where they can now actually provide analytics on the data coming in from their routers and switches deployed in a customer environment and advising customers up front rather than the customer relying on their NOC. And because these vendors understand much deeper what these messages are from those boxes and able to analyze them much better. So providing analytic capabilities on products like your networking equipment and servers directly is a big value. Now, the other one on this page here is from our own one of our customers here in the machine-to-machine carrier space. There's data coming in from cars, automobiles, the soil sensors in wineries, oil fields, fleet trucks, etc., that's being routed in real time through this network onto, of course, their back office. And they're applying real-time rules and alerts. And in each industry, like automobiles or wineries or oil fields, it lends into very interesting use cases. And their customers, which is the car manufacturer or the winery or the oil field, is now getting early alerts from this carrier because of this real-time analytics and putting in business rules on the data as it flows in. Again, that's a value-added service by this customer, and this is a billing and analytics group in this carrier that we are working with. And that's, again, an interesting use case we thought we'd share. So coming to retail, which we're all very interested in, customer lifetime value is a huge metric that we have seen over and over again, be it online retailers or brick and mortar. And everybody in the retail space is, of course, trying to get a sense of a single view of the customer across different channels, which is, the mobile channel, the POS, actual brick and mortar operations and the transactions at the store. So they're trying to do propensity to buy analysis. What is this person likely to buy? What is his lifetime value? This is a high-profile customer, and getting that single view of the customer across channels. And another interesting use case that we came across was a combination of telco and retail, being able to triangulate your wireless signals and actually see upfront before, for example, on a major holiday, what kind of retail success is going to happen across in that particular store by seeing the population of the number of cars and the number of people in a particular parking lot around, say, a Best Buy or a Toys R Us. And the issue with retail is that retailers are only get an insight of who is this customer after the customer bought and checked out. But using the triangulation of mobile and mobile apps and the network feeds, you can actually detect customers as they come in and serve them better based on who they are, instead of finding out, well, this person came and went, and we couldn't do anything about it. So, yeah, moving forward on one more interesting app or application or use case on the retail staffing operations that we saw was retailers have, in large departmental stores, they have limited staff. They want to know where to put that limited staff. Now, and they're doing active promotions. Their competition is doing promotions. They're looking at this particular product vendor created a solution which we assisted in analyzing social media data to see how consumers are reacting to promotions and predicting what areas of the store they need more staffing around. And so it's adaptive staffing based on social media feeds. That's what the use case was.
All right, great. Let's take a quick break. I want to give everybody the results from our last poll while you take our this final poll during our session. So as everybody could probably guess, it was all about the money. The poll indicated 40% of the audience wants to focus on revenue and 25% on cost and still some on risk. So probably not a surprise to everybody. I do think we're going to take a quick minute and just catch a couple of questions here. So AV, somebody's asked, are there established system test methodologies for an environment with Hadoop and other big data components?
Right. I wouldn't say there are established methodologies. Hadoop is a data infrastructure, and it doesn't do a whole lot of disruption to the application paradigm. Applications are still written in languages like Java, but the paradigm of MapReduce or parallel distributed applications is what provides the challenge. We are, of course, developing some of our own tools in the test engineering group that we have around this. The answer is, at the moment, no, but we see all our customers asking about this, and we're working on it.
Great. One more question as we're running out of time today. In the case of manufacturing, does the underlying communication network need to change for supporting big data?
Absolutely. We have seen 10,000 times more data being collected by these machines because they're sampling at a much higher frequency, and there are many, many more sensors. So there's two-way n-square multiplication of the current data set. So the fiber in the network level carrying the data needs to be expanded to, if it's 10 gig, it probably has to become 100 gigs, and so on.
All right, great. Let's keep going as we're running out of time today, and we'll get to some more questions.
Great. So you might be wondering, that we have probably not covered certain aspects or use cases that you were thinking about from an audience perspective, and that's because these are horizontal use cases which are identically applicable to all industry verticals, and we have clearly seen many of those, and they're the more familiar talked about use cases that we'll just quickly breeze through now. So the IT department is one of our obviously big target customers that we come across. Either they're serving a business unit or they have applications or use cases on their own. And we've seen use cases around data warehouse replacement in certain applications with the Hadoop and Hadoop storage mechanism, right, and storage and processing for reporting and BI tasks. We've also seen ETL functions being offloaded from expensive traditional data warehouses over into Hadoop and MapReduce. So we've had large banks actually being, considering enterprise-wide replacements of some major ETL tools using Hadoop-based technologies as a proof of concept. And it's a ton of savings, and they definitely want to investigate whether it's possible or not, and we have clearly seen it is possible. Monitoring and management of servers and applications, clearly the Splunk use case that everybody's interested in for sure is a big data use case we've seen across the board. A major telco came to us for security event detection, both real-time analytics on security events so that they can increase the accuracy and analyze all possible events, and learning from a batch analytics perspective, patterns of security breaches and proactive prevention mechanisms. So moving forward into more horizontals that cut across verticals, we have contact center analytics, and again, the value drivers definitely are the reduction in cost, increased revenue, and risk. So all of them are covered in this. And this is, mind you, the voice of the customer, right? We see that contact center scripts and data are one of the least leveraged data sets just because it's so unstructured, it's language intensive, and that's where this whole technology of ever-improving technology of natural language processing comes in. So some of the use cases that we've seen here are people finding actually the contact center employee, this is an HR situation, they found that experience is not really as important as personality, and personality was more the focus because contact centers want to keep employees for at least 1 year after their training. They invest in training. They want to find out what kind of people will stick on for at least a year. And they found using big data analytics that personality was much an important metric than just years of experience. On the loss reduction or risk mitigation side, customer churn analytics is something that we are heavily invested in across verticals. And one of the data points for that is, of course, the interaction from the customer with the customer center, with the call center agent. How did that go? What were the keywords? Searching, the ability to search keywords across the entire database of contact center scripts, looking at patterns that predict customer behavior or a loss in sentiment or customer morale across an enterprise. Now, on the revenue and again on the cost side, the channel and campaign management. So there's a customer of ours that's analyzing outbound calling and the quality of those calls. How did that go to analyze which are the best channels that are producing the most productive results and profitable results? And an interesting use case we saw was proactive fault isolation in telco networks using the complaints that customers call in with, and keyword analysis pointing to predictive indication of network faults even earlier than the equipment reported it. I would say even earlier than what they could find from the equipment. So on the web analytics and digital marketing front, again, it is one of the top use case patterns that we see across industry verticals. And all customers, no matter whether it is financial institution, retail, online retailer, and other verticals, they want to know what their customers are doing on the web. Where did they come from? Where did they go? What behavior results in a sale or a purchase? What prior indication is there that we can predict, and we can grab this customer, do upsell, cross-sell, and so customer behavior and segmentation analytics is also very, very common across using social media. And we'll come to the social media use cases in the final slide, the next one. And ever increasing, I would love to say that the ad effectiveness is actually dramatically increasing and it's up to where it should be, but I still see ads of things that I already bought and I'm not going to buy again for sure for a long, long time. I wish the systems knew. So there's plenty of optimization, I think, potential there in the internet advertising space as well. On social media analytics, we have in fact taken into production very interesting use cases. For a major credit card company, we analyzed brand reputation against their competition based on a large segment of Twitter data. And we actually found some very interesting things that we fed back to them. So we did both volume of mentions in terms of X brand versus the top 3 competing brands, and we did a detailed analysis on sentiment, or what was the positives, what are the negatives, and using your machine learning algorithms to start learning and getting more and more accurate on what is a negative sentiment versus positive, and that can be pretty tricky because of the way English is. On the graph analytics and social media, graph analytics applied to social media, the big area of focus is who influences whom, who are the influencers, how do we get them to influence our brand or the rest of the community on our product or service. And I think it's been found that there's a huge impact of friends, and that report was actually put out by one of our own customers. Now I mentioned the retail staffing operations and proactive customer complaints resolution based on real-time analytics as well. So, I know we're running through a lot of content, and I just want to assure you that there will be webinars, there'll be more detailed discussions we will have in 2013 around these, and feel free to engage with us. So here's what we talked about, the definition, value, and use cases, and I want to move on to the final segment, which is the how-to piece. A major bank's IT director said this: big data strategy is a journey, not a destination. It's not a product you're just going to buy. It's not something you're going to just stand up there and be done with. In fact, that is actually just the beginning. And literally your challenges and problems begin there if you thought that it was a big challenge to choose a particular product or technology. So we are putting out here a generic pattern which seems to be working well across the early adopters. First, focus on strategy, which is business goals. What really are the business goals? And there's always some hypotheses around business goals saying, hey, if I tune this, I think we can accomplish higher profitability, or we can create new products in this particular space. I have a suspicion that customers are doing this. So there's business goals and there's hypotheses on how to create or achieve those business goals. That comes first. You then go and locate and collate all the data that feeds the analysis of those hypotheses. And you then go about integrating all of that and do a proof of value exercise. That's what these are also. This chart is mapped to our own service offerings here at Impetus. And this is how we have structured our service offerings based on what we have seen in the last 2 to 3 years of customers and the way they're progressing in their big data journey. So a proof of value or ROI exercise is conducted with a small budget in a 4 to 6 week exercise with data architects and data scientists, and that fuels the decision on the executive approval of the budget and overall the technology stack. You then move to the proof of concept stage and identify a set of use cases that constitute your roadmap, your short-term, mid-term, long-term, and design and implement use cases or proof of concepts that typically put one technology stack against the other, one vendor against the other in terms of you select your top two first using a theoretical or interviews, and then get into an actual POC and make your final choice, and then you look at production and moving into the production stage. In the production stage, it's all about, of course, implementing, integrating, optimizing, and there's a ton of issues, including operations, people skills, what new skills you need, what new types of people you need in terms of partnerships, and once that is stabilized, you're able to absorb that impact of the new paradigm using one or two pilot use cases. You then start expanding on the platform and adding more and more use cases across different departments, across different business units. So that's our view of a high-level picture of a rollout strategy. And I want to come to a close here with a value punch in a way. If people are still thinking and not able to justify the value of big data, here are a few samples. The value of that fraud accuracy use case I was talking about earlier was estimated to be about $112 million. That was new revenue added just by implementing that single use case. One of our customers has been able to eliminate 48 RDBMS licenses out in using a new big data technology that they ended up using, and that was part of an example of a horizontal use case of IT transformation to big data. And we're definitely not saying this is a replacement story. It is an augmentation story. It is an offload story. So you still need your OLTP. You still need your Teradata's and Oracles of the world. But each of them, of course, have their own now big data strategy, which they very well augment with the existing infrastructure. The New York Times case study, that's the number 3. We definitely don't claim to be involved in that, but it is a age-old, great example of a very large task, 11 million plus documents and articles converted into PDF with less than $300, and that was done on the cloud using Hadoop. And our own customer, one of our customers who's a media company, has been able to launch a Hispanic consumer data analytics business because they believe that particular segment is underestimated, undervalued, and they're putting a whole business. We have them put a big data analytics stack together for that use case. Just want to end with a little bit of coverage on who we are, what we do, and I've kind of touched upon that indirectly in this presentation. Impetus offers advisors, architects, and applications in the big data space, right? So we have advisors. We advise you on the strategy because we have the experience. We've gathered that because we're a first mover in the services space in big data analytics. We've acquired the expertise, and we have deep thinking, wide-ranging architects that can think across different technologies and advise you on the best match for your use case. We are thankfully unbiased. We are vendor agnostic. We work with all the leading industry vendors and bring them in, but we don't have a particular favorite in any use case or in any situation. And we actually build analytical applications and have a keen eye on the delivery. We're 17 years in the business. This is not new to us. The big data part is about 4 years old. So I'd like to end with that little pitch about us.
Thanks, A.V. Let's get a couple more questions in before we leave today. The use cases here are mostly in the private sector. Do you have any specific examples in the public sector?
I don't know if you have looked at this, but President Obama actually put together a big data analytics committee. And the government is the single biggest user of big data. That's where a lot of money is being made by big data vendors. We've seen use cases in the social security space, both in the military and civil space. So there's a ton of action in the public space, in the public sector, and the energy and utilities is another area where there is a lot of big data use cases happening, and of course healthcare. We have data scientists working on cancer and diabetes use cases to predict the occurrence and reduce hospitalization. So I didn't even mention some of these because they're sort of all pervasive and they're very complex, large-scale use cases, and they're real.
Great. Speaking of energy, have you seen any use cases in the wind and solar and any of the alternative energy sources?
Yes, we have seen, like I mentioned, sensor data, data coming in from windmills. That's an important use case that we worked with one of our partners, and that clearly was a new energy space vertical. Our partners keep asking us about our depth of experience in energy. We're not particularly very exposed to the energy sector, but we have seen and operated on a few use cases. But the beauty of this is, like I said, there are patterns across verticals that are identical, so we can actually work on any of these use cases.
Great. One last question. Does Hadoop have data router functionality that it can help in managing the interaction with the source systems?
Does Hadoop have a data router functionality that can help in managing the interaction with the source systems? So let me try to answer this. I'm not sure if I got it right, but there are interfaces into Hadoop, such as like what I mentioned, Scoop or Flume, and other technologies that are interfacing with the source systems, which could be your traditional databases. And there are workflows that can manage the entire process.
Great. Thank you. That's all we have time for today. We will continue to answer the questions that we receive in email. I want to take a moment to thank AV and all of our audience for your time and interactions. We are looking forward to a great year with more opportunities to meet and strategize with everyone. We invite you to be part of our upcoming Thought Leadership event. As an example, later this month on January 24th, you can join AV along with the rest of some of the Impetus leadership at our Data Innovation Celebration Day in Santa Clara at the Biltmore. Also, AV is moderating a panel at the IE Summit in Las Vegas, January 30 and 31st, where you can also hear from some of our key clients and interact with them. You can learn more about these events, discover more about Impetus, request more information at bigdata.impetus.com, and as always, you can email us at bigdata@impetus.com. Thank you for joining us, and have a great day.
Thank you, Joanne, and everybody.